Hello YouTube, De-bodgery here. So, my first video in this little series, I just wanted to focus on the BMS and a little bit about the app. Highly hackable BMSs. I love these things. They work super well. I have probably bought 20 of them and sold off probably 10 of them to friends, after I mod them. And of course, all of my EVs, of which I have 4, they originally ran with Smart BMSs because, like everybody else, I've got a limited amount of money. And now they've all been switched over to Smart BMSs because these Smart BM and these specific ones that use this Xiaojing app specifically. And the reason why is because they're just not that much money. They work well. They're highly hackable. So, maybe I can't get one that does exactly what I want straight from the factory. After I mod the thing, replace MOSFETs, improve copper buses, things like that, they do exactly what I want afterwards. So, pretty darn happy with these BMSs. The early versions of them, they did have a problem where the temperature connections didn't work very reliably, and so once a temp sensor would disconnect, you'd get a low temperature, and the BMS would disable, which was annoying. So my solution to that was simply take the temp sensor out, and solder the temp sensor wires directly to the pins on the connector, and that fixed that problem. No more problems after that. But anyway, they've now gone to this new connector, which got like a little clippy thing on it. I don't know why that's showing up on camera. But yeah, these ones don't seem to have any problems. So, that was like my only actual issue with them, and that's been fixed. So let's talk a little bit what I've got in this box. So first of all, I've got my clamp-on Klein Tools amp meter. Over here, I have a little 3 amp 82 volt charger. And right now, this battery pack over here is made out of Samsung INR 18650B 3400 milliamp hour cells in 9S20p. It is connected to the BMS. So this pack is brand new. It has never been on a charger in this form ever before. And as a result, none of the cells are balanced, and it's never been on a BMS either. So when I show you the app, you'll see that the cells are kind of all over the place. All right, so this pack right here, this one is much older, about 2 years old, and it is made out of Samsung 30Q cells, 30 amp hour cells. So between the two, with conservative numbers, because you never get the full capacity that the manufacturer says from, lithium ion cell, I'm going to say I'm going to get about 60 amp hours or so of total capacity between these two packs. This pack is in really good shape. I've already tested it. I know what it's doing, and it's doing about 28 amp hours, and of real life use. And this one, well, I don't know yet. I've just built it, but I'll find out soon enough. Anyway, so what I want to show you is what the BMS is doing, and that was just all basically introductory. So this is the charging connector, and right now, so you can see this wire right here with that connector on it. That goes over here to C-, and this red wire is connected up to BAT+ on this one battery pack. Eventually, this cable right here, which has got 2 connectors on it, so here's the one for the new Panasonic pack, and here's the one for the old Samsung pack, and here's its connectors. They'll all be connected in parallel together on the same BMS, but right now I just want to get this this brand new pack balanced. So this is all disconnected for the moment. All right. Anyway, so what I want to show you is what happens with a pack that is kind of out of balance. All right, so here is the app, and I'm going to put that over here like this so I can manipulate things. Let's go back. Then we go to battery state. All right, so you will notice that cells 1 through 10 are all in the 3.9 plus volts range, and cells 11 through 20 are all up there at 4.14, 4.15 voltage range. All right, so these ones are all over voltage because 4.1 volts is really what I want, and these ones are all still under voltage. So the BMS is slowly bringing everything up into complete balance. But because it's a fresh pack, it's never been balance charged before, so things are not balanced yet. All right, so here is what's happening. So you'll notice that you see those green bees blinking. That's indicating that a cell is being balanced. There you go, just saw a bunch of them. You'll notice that the only one that doesn't do that is this cell right here, which the capacity, green capacity, flashes on it, because that's the lowest cell in the bunch. And then there's another one over here that flashes, and that's like the highest voltage cell. So low and high flash, which is, there we go. So low to high flash, indicating that you have, these two cells are the two that are most divergent from each other, which is kind of handy. It quickly tells you status of your cells in your pack. Based on that kind of information. So anyway, that low cell right there, you'll never see the B turn on, at least not right now, not until it comes up to voltage, just because there is, it's under the balance voltage right now, so it's never going to balance. Anyway, it'll get there. So here is what happens. Those cells down at the bottom, 11 through 20, according to the settings I've got in the BMS, they will balance the BMS will balance them down to that 4.15 volts, which I have set in the param setting page. And when that happens, the BMS, through its C- connection over here for charging, will turn on those MOSFETs and allow the charger to push current in the battery pack. And that is to bring these cells, 1 through 10, up to voltage. And it's going to take a little while for this to happen and to finally get done. Oops, my phone was starting to go to sleep. But it will eventually get there. So anyway, let's see that in action. Right now the clamp-on meter shows 0.2 amps, basically negligible. And if I go back here to the dashboard, that charge says 0 as well. So I'm going to fake it because, I'm trying to do this on camera. So what I'm going to do is I'm going to go into param settings. And I'm going to change this 4.15 to 4.18 because there's no cells that high. And then I'm going to go down to submit. Okay, so it's writing. There we go. And you'll notice the green light on the charger, this rightmost light, turned red. And now I'm showing 2.5 amps. And I go over the dashboard and I'm showing, nope, so just switch back off again. Yeah, no, it's back on again, so the light's back on. It's kind of blinking. It's not quite sure what it's doing. But, yeah, so you can see I'm showing amp draw here. And there we go. So the amp, yeah, showing like 2.8, 2.9 amps. So it's like right on the verge of staying on, shutting off. But this cycling on and off, like you're seeing here, in the balancing process, I'll see this happen like once every 30 minutes or 40 minutes or so, as the BMS allows charge current in to bring up those low cells, and as the higher voltage cells are balanced down to that lower setting, of course, which that's now is 4.18 volts. Yeah, and you'll notice up top here there's that OV that turns on and off. Yeah, indicating that cells are over voltage. We're still fine. Once or twice charging at 4.2 volts is not a problem for lithium ion. It's just not the thing that you want to do all the time. So later on I'll change that back. But this is basically just to bring up those cells to get things moving. Anyway, really what I wanted to show was this kind of a cycling effect, which is much faster now because I changed that cutoff voltage. But yeah, normally it shows that light turn red for like a minute or two, and then stays off for like 40 minutes as it's bringing up those low cells. But yeah, it's essentially balancing those lower cells upwards as much as it can without overcharging those higher cells. And if I go back into battery state, yeah, that's what we should see. So these cells 1 through 10 are coming up, and the balancing function of the BMS is trying to take these higher cells, of which you'll see like there's some 4.2s in there. It's trying to bring those cells back down again. So when these cells reach 4.2 volts, the BMS shuts off C-, and that's why you see that pulsing. But when those cells come back down again, i.e. there's not a voltage applied to them, then they drop off their voltage a little bit, in which case the BMS turns back on again. And that's why this is flashing on and off, because the BMS is sensing cells are over voltage, i.e. 4.2 volts, So it shuts off, and then those cells immediately drop below 4.2 volts again, so the BMS turns back on. And in the process, these lower cells, cells 1 through 10, are slowly coming up to charge. So I just wanted to show you balancing in action.